Pluto's story is a fascinating chapter in the history of astronomy that highlights both how our understanding of the cosmos evolves and how important clear definitions are in science. Discovered in 1930 by Clyde Tombaugh at the Lowell Observatory, Pluto enjoyed nearly 75 years as the ninth planet from the Sun. For many, it was an emblematic member of the solar system, nestled beyond Neptune, a distant world shrouded in mystery. Yet a pivotal moment arrived in 2006 when the International Astronomical Union, IAU, redefined what it means to be a planet, and Pluto was demoted to a new category called dwarf planet. This decision sparked intense debate, passionate disagreement, and a surge of public interest. And it still sounds surprising today to hear someone say, Pluto isn't a planet anymore. So why exactly did this happen, and what does it mean? The heart of the controversy lies in how we define planet. Before the 21st century, the word planet was used quite loosely, mostly to mean large bodies orbiting the Sun that we can see moving against the backdrop of stars. This classic list included Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. But as telescopes improved and new objects were discovered in the far reaches of the solar system, astronomers realized the need for a more rigorous definition. The discovery of Eris in 2005, a distant object similar in size to Pluto but located even farther away, intensified the discussion. If Eris was a planet, then perhaps dozens or even hundreds of similarly sized bodies in the outer solar system should also count as planets. That would dramatically increase the number of planets and blur the categorical lines astronomers and educators relied on. Responding to this challenge, the IAU convened a working group that settled on a clear set of criteria to determine what counts as a planet within our solar system. Approved at their General Assembly in Prague in August 2006, the official definition states that a celestial body must satisfy three conditions to earn planet status. 1. It must orbit the Sun. 2. It must be massive enough that its own gravity pulls it into a nearly round shape. This distinguishes planets from irregularly shaped asteroids or comet fragments. 3. It must have cleared its neighborhood around its orbit. Let's unpack the significance of each point. The first is straightforward. The object must directly orbit our Sun, which excludes moons like Earth's own moon, which orbit planets rather than the Sun. The second point requires the body to be in hydrostatic equilibrium, meaning gravity has pulled it into a shape that's close to a sphere. This excludes odd-shaped rocks and small bodies that don't have sufficient mass for their gravity to mold their shape. The third and most contentious is the cleared its neighborhood criterion. Clearing the neighborhood means the planet's gravity has either accreted smaller objects, ejected them, or otherwise dominated all other debris near its orbit. Essentially, the planet has swept its path to a sort of gravitational dominance or cleanliness. Pluto meets the first two criteria easily. It orbits the Sun and is spherical enough, thanks to its gravity, for a rounded shape. However, Pluto falls short on the third condition. Its orbit lies in a region called the Kuiper Belt, a ring of small icy bodies and remnants from the solar system's formation. Unlike the large planets, Pluto shares this region with many other objects of similar size and smaller, meaning it hasn't cleared its orbit. Instead, it coexists with a host of other trans-Neptunian objects. In terms of gravitational dominance, Pluto is more like these Kuiper Belt objects than it is like the 8 classical planets. Consequently, Pluto was reclassified as a dwarf planet. This category includes bodies that are spherical and orbit the Sun, but have not cleared their orbital neighborhoods. Along with Pluto, the IAU recognized Eris, Haumea, Makemake, and Ceres, a significant object in the asteroid belt between Mars and Jupiter, as dwarf planets. This decision was met with a mix of scientific approval, public disappointment, and cultural resistance. Many people had grown up learning that Pluto was the ninth planet, and the reclassification felt like a demotion, even a betrayal. Some astronomers disagreed, arguing that the clearing the neighborhood rule was not a perfect measure, and that Pluto's complex and intriguing nature deserved planetary status. Others appreciated the clarity the new definition brought while acknowledging that science often requires revising previous ideas based on new evidence. What makes Pluto special, despite its dwarf planet status? For starters, Pluto is an unusually complex and dynamic world for something so small, only about 2/3 the diameter of Earth's moon. Thanks to NASA's New Horizons mission, which flew by in 2015, we now know that Pluto has a varied surface with mountains of water ice, vast plains of nitrogen and methane ices, and a thin atmosphere that changes with its seasons. New Horizons revealed features like Sputnik Planitia, a huge, heart-shaped nitrogen ice plain, and even signs that Pluto might have a subsurface ocean beneath its icy crust. These discoveries have transformed Pluto from a distant point of light to an object of immense scientific interest. Moreover, Pluto has a complex system of moons, with at least 5 known, including Charon, which is half Pluto's size. Charon is so large compared to Pluto that the two bodies actually orbit a point in space between them, often leading scientists to refer to Pluto-Charon as a binary system, a pairing rather than a primary planet and satellite. This proximity has interesting gravitational and tidal effects, locking the two in synchronous rotation, with each always showing the same face to the other, similar to how Earth's moon does with us. In the broader sense, Pluto is a key member of the Kuiper Belt, a treasure trove of icy bodies that offers clues about the solar system's early days. Studying Pluto and its kin helps scientists understand how planets formed and evolved, how volatile ices migrate on distant worlds, and what conditions might be like in the most remote corners of our planetary neighborhood. The existence of objects like Pluto challenges our definitions and pushes astronomy to keep adapting and refining our view of what makes a planet. In the end, Pluto remains a beloved cosmic neighbor, not just for its status, but for its unique characteristics and the window it offers into a distant, icy region of space. While it may no longer hold the official title of planet, Pluto's story reminds us that science is an ongoing process of discovery and change, shaped by new knowledge and better understanding. This reclassification also had practical implications for education and how solar system models are presented. Textbooks had to be updated, experts sought new ways to explain the solar system's architecture, and scientists turned their attention to a richer inventory of small bodies populating the sun's outskirts. Rather than diminishing Pluto's importance, this spotlight intensified research into dwarf planets and comparative planetology. Understanding why Pluto lost its planetary status involves appreciating the complexity and nuance of defining terms in science. Not only does it highlight the importance of classification systems adapted to new data, but it also exemplifies how science balances between tradition, clarity, and discovery. Pluto is no longer a planet by the IAU standards, yet it remains one of the most intriguing and scientifically valuable objects in our solar system. Its legacy continues through ongoing research, future missions, and the curiosity it inspires about worlds beyond the familiar planets. The story of Pluto's reclassification also invites us to consider how the boundaries of scientific categories evolve as our technology and knowledge improve. Looking back, it is easy to see why Pluto was initially labeled a planet. The discovery of a distant world moving against the starry background was monumental, captured the public imagination, and fit neatly into the known solar system structure. Over time, however, advances in telescopes and observation techniques uncovered a much more crowded and dynamic environment beyond Neptune. We learned that Pluto had company, many objects sharing a similar size, orbit, and composition. The Kuiper Belt, once only a theoretical prediction, was suddenly a bustling region filled with icy bodies, dwarf planets, and debris. This broader perspective led astronomers to reconsider whether Pluto should rank alongside the much larger planets like Jupiter or Earth. If we imagine our solar system as a city, the classical planets are the major landmarks, dominating the skyline. Pluto, in contrast, is more like one of many smaller houses in a vast suburban neighborhood. Recognizing and naming this neighborhood accurately is crucial for scientists seeking to navigate and understand it. The criteria set by the IAU aim to provide a working framework rather than a final, unchanging edict. In fact, the nuances of this definition continue to be a subject of discussion among experts. Some planetary scientists argue that the clearing the neighborhood criterion does not perfectly apply to extrasolar planets or small stars, and alternative definitions have surfaced based on formation history or geophysical properties. These debates illustrate that even scientific classifications are provisional and subject to revision as new data and perspectives emerge. Looking beyond Pluto's classification itself, the discovery of objects like Eris invigorated the search for similar distant worlds, some potentially rivaling Earth's size or even exceeding Pluto's. In recent years, astronomers have identified several more dwarf planets in the Kuiper Belt and beyond, leading to the recognition of a complex menagerie of minor planets. This has intensified inquiries into the outer solar system's structure and origin. Moreover, the Kuiper Belt and its inhabitants hold clues to understanding the solar system's formation. The arrangement, composition, and orbits of these bodies offer a fossil record of the early solar system's accretion processes. Pluto and its neighbors represent remnants of the primordial disk of material that orbited the young sun about 4.6 billion years ago. By studying these objects, scientists hope to piece together the history of planetary migration, collisions, and the shaping forces that led to the solar system as we see it today. In addition to the Kuiper Belt, another important region of small bodies exists closer to Jupiter, the asteroid belt, home to Ceres, the first dwarf planet identified. Ceres differs notably from Pluto, being more rocky than icy, and residing much nearer to the Sun. Its inclusion as a dwarf planet reflects how the IAU criteria apply across different parts of the solar system. Both remain scientifically valuable because they blur the boundaries between smaller, irregularly shaped bodies and true planets, helping astronomers understand the continuum of objects from tiny asteroids to planetary giants. The nuanced approach to classification also mirrors challenges in other scientific fields, where categories struggle to keep pace with complexity and new discoveries. Defining what exactly constitutes a planet requires wrestling with questions of scale, composition, orbit, and formation, and no single parameter fully captures the rich diversity of celestial objects. This complexity shows how scientific taxonomies evolve, a reminder that definitions are tools for understanding, not absolutes etched in stone. Public reaction to Pluto's reclassification illustrates how scientific changes can intersect with culture and emotion. For many, Pluto's loss of planetary status felt like an emotional upheaval, symbolizing not just a change in scientific understanding, but a shift in identity and nostalgia. The image of Pluto as the ninth planet was ingrained in schoolbooks, media, and popular imagination. Its star-shaped heart seen in New Horizons photographs has only deepened affection for this icy world. This emotional connection reveals the significant role that science communication and education play in helping society adapt to new realities. Interestingly, Pluto's reclassification has also acted as a gateway for broader public interest in astronomy and planetary science. The lively debates, media attention, and awe-inspiring images from missions like New Horizons encouraged many to learn more about the solar system's complexity. This interest has supported continuing missions, telescopic surveys, and experiments aimed at understanding planetary systems both here and beyond. The recognition of dwarf planets like Pluto expands our conception of what it means to be a world. It highlights the diversity of objects orbiting our star, ranging from giant gas planets to ice-rich dwarf planets and small moons. This richness strengthens the idea that our solar system is a dynamic and varied collection of environments, every one of which offers clues about the processes that govern planetary science. Looking forward, the study of Plutonian systems continues to evolve. Scientists are investigating Pluto's atmosphere, surface geology, internal structure, and possible subsurface ocean through both analysis of New Horizons data and telescopic observations. These studies help illuminate how small worlds can maintain geological activity and atmospheres despite their isolation, low temperatures, and distance from the Sun. Furthermore, Pluto is part of a larger group of objects known as trans-Neptunian objects, TNOs. These bodies orbit the Sun beyond Neptune and vary widely in size, shape, and orbital characteristics. Some, like Sedna and Quaoar, are even more distant than Pluto and may represent a population of objects hinting at the mysterious and not fully understood outer edge of the solar system, or a hypothesized Planet 9. The discovery and exploration of these distant realms continue to challenge conventional ideas. Scientists ask profound questions. Could there be more undiscovered dwarf planets? What roles did these bodies play in delivering water and organic molecules to the inner planets? How do interactions in the Kuiper Belt inform us about planetary migration and solar system evolution? Each answer often uncovers more questions, driving a continuous quest for knowledge. In summary, Pluto's journey from planet to dwarf planet is more than a story of classification. It is a reflection of the growth of human knowledge and understanding, the adaptability of scientific language, and the allure of discovery. Pluto remains a fascinating world, not diminished by its title but enriched by its complex nature and the questions it inspires. As we continue to explore our solar neighborhood and beyond, Pluto exemplifies how science embraces curiosity, precision, and wonder in the face of the unknown.